receding. This is the beautiful Athabasca Glacier in between Banff and Jasper. 1890, that's where the glacier was in 1890, about a mile out, almost to where the highway is. And right now it's backed up into here. By the way, the reason it was out there in 1890 is because all the glaciers in the world advanced during what's called the Little Ice Age, which should give people a hint that there may be some natural fluctuations in the climate that cause these global changes. And there are, which I will get to soon. But we do observe global warming. The warming, though, hardly any of it in the southern hemisphere or the tropics, has been mainly at night and in the winter and in the northern hemisphere. And in the northern hemisphere, it is more dramatic at the higher latitudes than in the lower latitudes, which, because it's at night in the winter, kind of reduces the idea of drought. Oh, and by the way, the new statistics coming out, besides no change in tornadoes and hurricanes, is that there's been no change in drought in all this time. So whatever warming we've had, the 1.2 degrees has really not caused any increase in droughts or heat waves over the earth, more than unusual. In fact, the worst droughts and worst heat waves were in the 1930s during the Dust Bowl era. So by the way, if it's at winter and night, I can really handle global warming where I live up in Montana. A fourth fact, there are natural cycles of climate change, mainly from volcanism and the sun. Now the volcanism, when it goes off, it produces all this ash and what's called aerosols, which are very small particles to be trapped in the stratosphere. But they sink after 1 to 3 years generally, and so the climate change is short term. But the sun, it's now known, has long-term climate change in it. And the way a way that is correlated with this is the sunspot cycles. There's a number of sunspot cycles. There's a 11-year sunspot cycle, there's a 22, there's a 100-year cycle, and I believe there's a 200 and a 400-year cycle, but there's all kinds of cycles. And the more sunspots you have on the sun, the warmer you are, which seems opposite of what you think, because a sunspot is a black spot that's cool. But the cool spots are more than made up by the hot spots called faculae. Here are the faculae right here, these spots right here, and these are the sunspots. So when you have high sunspots, you have a lot of faculae. So essentially, you can keep track of how much heat you're coming from the sun by the number of sunspots. When you have a lot of sunspots, you have more heat coming from the sun. When you have a low number of sunspots, you have less heat. So, and these are, besides short period 11-year and 22-year cycles, there's long period cycles on the sun. In fact, we've been measuring sunspots since about 1610, since about the time of the invention of the telescope. And here's the curve of the sunspots. This is a smooth curve. Here is your 11-year sunspot cycle right in here. But we have periods in the past where we've hardly had any sunspots for years, like the Maunder minimum, where we had between 1645 and 1715, we had hardly any sunspots observed. In fact, I think it's 40 or 50 total in 70 years when we should have 40 or 50,000 sunspots. So then that was the coolest time of the Little Ice Age, right in there. And here is another little min right in here. Now, there's about the Maunder minimum, 40 or 50 sunspots when we should have 40 or 50,000. But by tree rings and carbon-14 and tree rings and beryllium-tin and ice cores, you can project beyond 1610, and we find another minimum about 1500s right in here. And then before that, we have a time of high sunspots. So essentially, from 1000 AD to about 1400, we have a period of generally a lot of sunspots. And then from about 1400 to about 1880, we're kind of low on sunspots. And then since about 1900, we've been high in the sunspot cycle. You can correlate these things with two big events that happened since about 800. One's called the Medieval Warm Period, centered about 1000 AD, and the Little Ice Age. And this is one guy's estimate on the temperature change in degrees centigrade. This is just published in 2008. The Medieval Warm Period. So that corresponds with the time when we had a lot of sunspot activity. The Little Ice Age corresponds to the time when we had low sunspot activity. So there's a strong correlation with the sunspot cycle on the sun going back to before 800 or 600 or something like that. The Medieval Warm Period was a time when you could grow grapes in southern England, which you can't now, and the Vikings colonized Greenland, and then when the Little Ice Age came, they disappeared. And now that the glaciers are receding in southwest Greenland, it's actually uncovering the farms. Some of the farms of the Vikings are being uncovered today, which indicates probably that the Medieval Warm Period was probably as warm as it is today. Now here's a time chart of the temperature, global temperature anomaly or change, the CO2 concentration, and the sunspot cycle. If you don't remember anything about this talk, I ask you to remember this, because to me this is the strongest evidence that there is a natural effects that are causing at least part of the global warming. Okay, let's take a look at this graph. Here's the increase in carbon dioxide, pretty low for quite a while, growing up very slow from about 1900 to about 1950, and then it goes up after World War II strongly. That's the CO2 concentration in the atmosphere. This is the temperature anomalies, the blue line. You could see it kind of wiggles around and doesn't do much until about 1910. Then from 1910 to 1940, it goes up considerably. So in 1930, we had some of the warmest temperatures that we've ever had in the United States, causing the Dust Bowl, as well as bad farming practices. And then, sometime about 1945,